Good morning, class. The session is being recorded. We are looking at section 4.1, maximum and minimum values. We cover 4 sections, maximum and minimum values, how derivatives affect the shape of a graph, optimization, and anti-derivatives. Differentiation formulas we should be very comfortable with. We looked at the concept of max and mean by finding critical points, which means we find f prime set it equal to 0 or f prime does not exist. We looked at definition of extrema. Extrema is the plural for extremum and refer to both max and mean. Local or relative means in some open interval, global or absolute means in the entire interval of the function. Fermat's theorem, local max and mean occur where f prime equal to 0 or f prime doesn't exist. In this example, a parabola opens up with the domain of all real numbers. There is an absolute mean, which is also a location of a local mean. There is no local max or absolute max. In the case of a closed interval, we have both absolute max and mean. We do not have local because the endpoints can only be absolute. Half open, half closed, we lose the minimum, we keep the max. If it's open on both sides, we lose both of them. It gives rise to the closed interval theorem in the case of a continuous function where there is an absolute max as well as absolute mean, and the methodology is outlined here, which simply put, you find the critical points, you evaluate the function at the critical points as well as the endpoints. The largest value is the absolute max, the smallest value is the absolute mean. So here's a simple example. We want to find the absolute max and mean values for the given function. F of x is 1/3 x cubed minus 9x in the interval of -6 to 0. Now, before we start with the methodology, number one, we have to establish the continuity. This function is a polynomial of degree 3, therefore it's continuous from negative to positive infinity. As a result, it is also continuous from -6 to 0. So that's the first thing we have to be very careful of. It's a polynomial of degree 3. So it's continuous from negative to positive infinity, and it is therefore continuous over the interval of -6 to 0. That means the closed interval theorem applies. Let's find f prime of x. So 1/3 times 3x squared makes it x squared minus 9x gives us -9. Because we want to set it equal to 0, we are going to factor it. So x squared minus 9 factored from x plus 3x minus 3. We set this equal to 0. This one gives us x equals -3. This gives us x equals +3. So there are two answers. However, take a look at the interval. -3 is clearly in between, but +3 is outside. So the only one we can use is -3. This is -3 is an element of, okay, that's a symbol in set theory. We read it as an element of. That means it's in between, everybody. Okay, so the next step is to find the functional value at the endpoints. That means you're going to plug in -6. That means you're going to plug in 0. as well as the critical points. There's only one critical point in between. You plug in -3. This is elementary algebra. You do the math. So you plug in -6 and it gives you -18. You plug in -3 and it gives you +18. And obviously 0 gives you 0 because this is 1/3 0 cubed minus 9 times 0. Now we want to write absolute max equals to the largest value. So absolute max is equal to 18 at, you can say x equals -3 or you give the pair -3, 18. Absolute mean is the smallest value, -18 at x equals -6 or at this pair. This is how you do the writing for 4 credit, everybody. Now, we are going to look at a couple more examples. Here's the next one, everybody. We want to find the absolute max and mean for the following function in the interval of -4 to 5. So the very first thing we need to establish is what type of function we have, what is the domain. So I'm going to rewrite this as the cube root of x plus 3 to the power of 2 minus 5. Which means, in essence, you're dealing with the cube root that is being raised to the power of 2. And the cube root, if you recall, the domain is all real numbers. So you are going to write, we are dealing with the cube root, and it's continuous from negative to positive infinity. Therefore, it's continuous in the given interval of -4 to 5. So first, we want to establish that. Now we go with the methodology and find f prime of x. It is in a format which we can use the power rule, or better yet, the extended power rule. So 2/3 sits in front. X plus 3 to the power of 2/3 minus 1 makes it -1/3 times the derivative of the parentheses, which is 1. And so this is simply 2/3 x plus 3 to the power of -1/3. And we are taking this -1/3 down and we make it +1/3. Now, f prime is 0, f prime doesn't exist. F prime equals 0. A fractional expression is equal to 0 when the numerator is 0. The numerator is a number. It doesn't matter. It's positive or negative or a fraction or any number. Therefore, f prime equals 0 doesn't give us any solutions. This is phi, a Greek letter representing an empty set. In set theory. That doesn't give us any answer. Okay. How about f prime doesn't exist? A fractional expression doesn't exist or undefined, is undefined when the denominator is 0. So if you set the denominator equal to 0, x becomes -3. So f prime doesn't exist. That means the denominator is 0. That means 3 times x plus 3 to the power of 1/3 is 0. That means x equals -3. Therefore, we can use the -3 because it's in the interval given. Okay. And so what we can do, we can evaluate the function at -4, +5, -3. And we come up with the answer. By the way, I hope you see that if you plug in -3 into the original function, clearly this one and this one become 0. So this goes away and you're left with -5. So that's very clear. So f of negative 3 is negative 5. I want to quickly show you why f of negative 4 is negative 4. Okay. So I'm going to use this expression, everybody. And I'm going to replace the x with negative 4. So if I put negative 4 with positive 3, it gives me negative 1. So I'm going to write that as cube root of negative 1 squared minus 5. Cube root of negative 1 is negative 1. I'm going to square it. I get positive 1 minus 5, and I get negative 4. I've already explained negative 3, so we have nothing to worry about. Now I'm going to put number 5 into this expression. So I'm going to put number 5, everybody. So that gives me 5 plus 3, which is 8. So I'm going to get cube root of 8 quantity squared minus 5, which is 2 squared minus 5, which is 4 minus 5 equals negative 1. Okay, so I wanted to make sure we understand the algebra behind that. So the largest number is negative 1, so absolute max equals negative 1 at this pair. Smallest number is negative 5, so the absolute mean is negative 5 at this pair. This is how you do the writing. I can't emphasize this enough, class. Okay, the way you do the writing, it's extremely important. You're telling your reader what you have discovered. I'm going to move on. We are repeating the same situation with a different function. F of x equals x over x squared plus 2. So the very first thing is to establish continuity and the domain. What type of function do we have here? Anybody knows what type of function we have here? What is the name? This is a, anyone? This is a rational function, because the numerator is
a function that can be written as,
because numerator is the polynomial of degree 1 or a linear function, and the bottom is a quadratic function, polynomial function of degree 2. A rational function, in order to establish the domain, you set the denominator equal to 0 and you exclude that. As you can see, the denominator is x squared plus 2, therefore it can never be 0, doesn't produce any real solutions. So the domain is all real numbers. Again, that is not the case for all rational functions. The reason this rational function has a domain which is all real numbers, because the denominator can never ever be 0. Therefore, the function is also continuous from 0 to 4. Let's differentiate using the quotient rule. So let's say the top is the f function, the bottom is the g function. So we are looking at f prime g minus g prime f over g squared. So the top gives us 1 times the bottom, x squared plus 2, minus g prime. The denominator gives us 2x times x over the bottom squared, or x squared plus 2 quantity squared. So that is the quotient rule. So we simplify the numerator by combining them as follows. X squared plus 2 minus 2x squared. And we can combine these two and we get minus x squared plus 2. Okay. Now, f prime equals 0. A fractional expression is 0 when the numerator is 0. So f prime equals 0. Minus x squared plus 2 is 0, which means x squared is 2, and x is plus minus square root of 2. And because you have two answers, and by the way, square root of 2 is about 1.41. So negative square root of 2 is negative 1.41 and it's outside. So it's only positive square root of 2 that we can use. Okay. And of course, f prime doesn't exist. You set this denominator equal to 0. We already know that this has no solution when we discuss the domain. Okay. So f prime doesn't exist. That means the denominator is 0 and it doesn't give us any solutions. We just stick with what we have, which is square root of 2. So we are going to plug in the end points as well as the critical point, square root of 2. So let's see what we get. Okay. Starting with 0, it's very simple. When you plug in 0, the numerator is 0. You get 0 over 2, which is 0. If you plug in a square root of 2, let me just quickly show you. If you plug in square root of 2, you get square root of 2 over. Now, when you square the square root of 2, you get 2 plus 2, and let me just rewrite this. So you get square root of 2, 2 plus 2, which is square root of 2 over 4. And you can, of course, rewrite this in decimal notation. If you plug in 4, you get 4 over 4 squared, which is 16, plus 2, which is 4 over 18. Simplification will give us 2 over 9. Now, if you recognize that square root of 2 over 4 is larger than 2 over 9, fine. If not, go with the decimal notation. Okay. And the reason you should know it's larger, because if you multiply 4 by 2, you get 8, which is almost 9. Square root of 2 by 2, you get 1.41 times 2, which is 2.8, and it's larger than that. Therefore, this is a larger number. And as far as decimal notation, this is about, okay, 0.2 or 0.2 bar. And so you establish absolute max is this number at this pair. Now, this number is approximately 0.35. And obviously, 0 is the smallest number, so that's your absolute mean, and it's at the pair 0, 0. The way you write it is extremely important. You want to make sure you write it properly, everybody. Okay. We are ready for the next example. Okay. We want to find the absolute max and mean for this case. So the very first thing we want to establish is what type of function we have. What is our domain? Anybody knows the type of function we have here? What type of a function is this? It is a polynomial of degree 4. Polynomial of degree 4. Therefore, the domain is all real numbers. Polynomial of degree 4. The domain is all real numbers. Negative to positive infinity. And we are fine with negative 4 to 1. Now let's go through the process of finding f prime. Differentiate step by step, term by term, x to the power of 4, 4x cubed, minus 18 times 2 minus 36x. And since we want to set it equal to 0, so 4x cubed minus 36x, we are going to take the GCF out, which is 4x. So 4x times x squared minus 9. We further factor this piece into x plus 3x minus 3. And so we come up with, when we set this equal to 0, we come up with 3 answers. X equals 0, x equals negative 3, x equals positive 3. So there are 3 answers so far. And f prime doesn't exist, doesn't give us any answer because it's a polynomial of degree 3. And if you look at those 3 answers, you are going to compare it with the given domain from negative 4 to 1. And you notice that 0 is in between. Negative 3 is in between, but positive 3 is outside, so that we cannot use. So 0 and negative 3 can be used. F prime doesn't exist, doesn't give us anything. And we are ready to plug in what? The endpoints, as well as the critical points within the given domain. Let's plug in. This is elementary algebra. You plug in negative 4, it gives you negative 32. You plug in negative 3, it gives you negative 81. 0 gives you 0. And the second endpoint, namely b, which is 1, gives you negative 17. I'm assuming everybody can see this is elementary algebra. You have to plug it into the original function and evaluate. And because it's a polynomial function, it's easy to evaluate. I'm going to leave it for you to do so. Now, how would you write the final result? How would you write the third step, class? Anybody want to share with us? How would you write the third step? Anyone?
Sorry, Professor. Why do we not test for positive 3?
Okay, let's go back to the given interval. The given interval is from negative 4 to 1.
Okay, I see.
And as you can see, positive 3 is not within the interval. Does that make sense?
Yes, it does.
Perfect. Thanks. That's excellent. Class, if you have a question, I appreciate that. You're not alone, I promise you. Please ask away. All right. Third step, the last step that we want to write. How do we do the writing? Can anybody tell me? So which one is the largest number? 0. So absolute max is 0 at the pair 0, 0. Which one is the smallest, everybody? Negative 81. So the absolute mean equals negative 81. At what pair? Negative 3, negative 81. It's important to be able to write this properly. Okay. Local extrema as well as absolute extrema refer to the value of the y coordinate of the function. Okay, everyone. So that's what's happening. Let's look at the last question, everybody. We want to find the absolute max and mean for this function in the given interval of negative 1 to 2. The very first thing we want to establish is what type of a function we have. So let me rewrite the function for you, class. So your function is a t, and then 4 minus t squared to the power of 1/2 means square root of a 4 minus t squared. So in essence, we are dealing with a square root function. And I hope you remember when we had y equals square root of x, the domain, whatever was under the radical, we would say larger than or equal to 0. So again, just to make sure we understand what we have a product of t, which is a linear function, or you can say polynomial of degree 1, and the square root. This doesn't give us any restriction t, but 4 minus t squared does, because it's a square root function, and therefore we are going to write 4 minus t squared larger than or equal to 0. And to establish that, if you recall, we do the sign graph. To do the sign graph, we are going to write this as factored form of 2 minus t, 2 plus t larger than or equal to 0. At negative 2, it's 0. At positive 2 is 0. I want to make sure that understands how we arrive at it. When you said this one equal to 0, t equals 2. When you said this one equal to 0, t equals negative 2. So, and I'm going to make this the easiest by picking up a value in between, because 0 is easy to pick. If you pick a 0 in between and you plug it into this, I hope you realize that it gives you positive times positive, which is positive. You can pick a test point here, negative 3, and that ultimately gives you negative here. You can pick up here positive 3, and it gives you negative. And the only answer is positive. Remember, we want 4 minus t squared to be positive, right? So let me use a different color in this case. So we want this one. Oh, I didn't pick a different color. Let's do that. And so what does that mean here? What does that mean? Okay, negative and 2. So I'm going to write, this is a square root function. It's really the product of a linear function and a square root. You want to write that to be more precise. It's the product of a linear function and a square root function. And we establish it's continuous from negative 2 to positive 2. Therefore, it's continuous from negative 1 to 2. And so first step is to find the critical point or points by differentiation. So let's do that. We are going to use this one to differentiate. It makes it easier. It is using the product rule. So t gives you 1 times the second piece. You just write it the way it is. Plus, so f prime g plus g prime f. I'm gonna, so f prime, this is f, this is g. Now differentiate this. Maybe I write that underneath here. So this is the f function. This whole thing is the g function, okay? So we are looking at f prime g. So that's 1 times that. Plus, now the derivative of this one is 1/2 4 minus t squared to the power of 1/2 minus 1, which makes it negative 1/2, by the chain rule times the derivative of the parentheses, which gives you negative 2t, by the product rule times f. So I'm going to write this for everybody so you can see what we have established here. We have, everybody, we have f prime G plus G prime F. So take a look. So let's quickly recap. I want to make sure that we have no problem with the differentiation because that's the main part. So T gives you 1 times, just write this. Plus, what about this part? 1/2 sits in front. 4 minus T squared to the power of 1/2 minus 1 is negative 1/2. By the chain rule, the derivative of the parentheses is negative 2T. And now times F by the product rule times the first piece, which is T. Now, all we have to do, just rewrite the whole thing and put them together. So how do we rewrite them? Number one, this is just the square root of 4 minus T squared. Plus this 1/2, this cancels out the negative 2 and just give us a negative sign. So negative 2 and positive 1/2, when you multiply them, they create a negative sign. Okay, then T and T, that's T squared. And this guy, negative 1/2 goes down, becomes positive 1/2, which is a square root. So let me quickly recap. So when you cross the 2 with 1/2, it creates this negative sign. Take a look. T and T gives us T squared. This is the denominator. So I hope you realize that now your common denominator is square root of 4 minus T squared. So if you multiply this one by 4, the first one by 4 minus T squared, this is what you are going to get. Let me just write this next step for you. So right now, if you take 4 minus T square root as a common denominator, this guy gets multiplied by that and it becomes 4 minus T squared. And the second one, you just write it as minus T squared. So you get 4 minus 2T squared in the numerator. I hope you see that. So I'm going to repeat one more time. You multiply this one basically by the denominator, it just comes out. That's how you take a common denominator. This is elementary algebra. Minus T squared, now these two, they add up to minus 2T squared. So going back to F prime equals 0. A fractional expression is 0 when the top is 0. So let's set that equal to 0. So when you do that, 2 squared equals 4, T squared equals 2, and T is plus minus square root of 2. Okay, everybody? F prime doesn't exist. A function, a fractional expression is undefined. It doesn't exist if the denominator equal to 0. So F prime doesn't exist if the denominator equal to 0. Now, denominator equal to 0 means four minus T squared equal to 0. That means T squared equals 4. That means T is plus minus 2. And so we have 4 numbers as critical numbers. Positive square root of 2, minus square root of 2. Positive 2, minus 2. So we have 4 numbers. We have to look at the given domain. Anything in between works. Anything that is not is out. So remember, square root of 2 again is 1.41. So square root of 2 works. It's in between because it's positive 1.41. But minus the square root of 2 is minus 1.41 and is out. Positive 2, it's one of the endpoints anyways, that works. But negative 2 is out. So we can only use those two. So how do we do that now? Well, plug in the endpoints and plug in those two. And by the way, one of them is the same. So plug in -1, plug in +2, also plug in square root of 2 into the original function. And you get the following. I'm going to show you how you arrive at the answer, okay? And we take it from there. So starting with -1. So look at this one, class, that we established at top here is t squared of 4 minus t squared. So I'm going to put -1 here. Take a look at what happens. If I put -1, I get -1 square root of 4 minus -1 squared. So I hope you realize -1 squared is 1, 4 minus that is 3. So you have -1 times the square root of 3. And that's how you get this one. Okay. Now we are going to look at the next part by putting square root of 2 inside. Let's see what happens. So I'm going to show you square root of 2. So for square root of 2, we get square root of 2, square root of 4 minus. Now square root of 2 squared is 2. So you get square root of 2 times square root of 2, which is 2. Finally, number 2. Put number 2 in here. I hope you realize that 4 minus 4 becomes 0. The square root of 0, so the product is 0. So if you plug into the square root, inside the square root is 0. Therefore, the largest number is 2 at this pair. The smallest number is negative square root of 3 at this pair. We write as follows. So absolute max equals 2 at square root of 2 comma 2. Absolute mean is minus square root of 3 at -1 comma negative square root of 3.